Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Meteoroids, meteors, and meteorites. A meteoroid is a small rocky or metallic body in orbit around the Sun, ranging in size from a dust grain to about 10 meters in diameter. A celestial body orbiting the Sun that is greater than a meteoroid and smaller than a planet is considered to be an asteroid, a comet, or a dwarf planet such as Pluto. Asteroids and comets may have a rocky or metallic composition, but comets contain frozen liquids or gases that evaporate and create a luminous tail as they approach the Sun. A meteor is a meteoroid that becomes incandescent and leaves a luminous trail as it enters the Earth's atmosphere. A bolide is a meteor with a fireball brighter than the planet Venus that explodes before reaching the ground. On February 15, 2013, a meteor streaked over the city of Chelyabinsk, Russia, with a population of 1.1 million. The meteor left a thick trail and exploded in the atmosphere with a bright flash. The shockwave of the explosion damaged buildings and shattered windows throughout the city. More than 1,000 people were injured by flying glass. The meteor was estimated to have a diameter of 17 meters and an explosive force of 500 kilotons. Meteor streams are bands of meteoroids dispersed along the orbital paths of disintegrating comets. Meteor showers can be observed when the Earth passes through meteor streams in its orbit around the Sun. Meteors are also called shooting stars. A meteorite is a meteoroid that has passed through the atmosphere as a meteor and survived the passage to actually impact the Earth. Meteorites are classified according to their composition. Stony meteorites, which are the most common, are composed of silicates, but up to 1/4 of their mass can come from iron and nickel. Iron meteorites, like the one illustrated here, and stony iron meteorites are thought to originate from the cores of differentiated asteroids that were once heated to the point where partial melting caused a geochemical aggregation of materials. The asteroid Vesta is an example of a differentiated asteroid because it has basaltic regions indicating that lava once flowed across its surface. Pallasites are stony iron meteorites that come from the boundary of the mantle and core of differentiated asteroids that broke apart by collisions during the formation of the solar system. Pallasites have olivine crystals composed of magnesium iron silicate embedded within an iron-nickel matrix. Stony meteorites can be classified as achondrites or chondrites. Achondrites are stony meteorites that do not contain chondrules. They consist of material similar to terrestrial basalts or plutonic rocks. Chondrites are stony meteorites that have not been modified due to melting or differentiation of the parent body. They are formed by the accretion of dust and small grains that were present in the early solar system. We tend to think of meteorite impacts as rare events, but on January 18, 2010, a meteorite the size of a mango weighing 308 grams punched a hole through the roof of a medical office in Lorton, Virginia, about 15 miles from the White House in Washington, D.C. Many witnesses along the east coast of the United States reported seeing the luminous meteor trail. The doctors leasing the office gave the meteorite to the Smithsonian's National Museum of Natural History, and Smithsonian officials planned to give them $5,000 in appreciation. The owners of the building said, "Not so fast." They claimed that the meteorite belonged to them because the meteorite fell on their property. They expected the meteorite to be worth at least $50,000. After some legal battles, the landlords dropped their claims and the doctors received $10,000 from the Smithsonian, which they donated to the charity Doctors Without Borders. The composition of chondrites depends on their origin. Enstatite chondrites comprise about 2% of the meteorites falling to Earth. Their most abundant component is a magnesium silicate mineral. It is thought that these chondrites formed within the orbit of Mars. Ordinary chondrites constitute about 74% of the meteorites falling to Earth. These meteorites are thought to originate from the inner portion of the asteroid belt between the orbits of Mars and Jupiter. Rumurtichondrites have a higher ratio of oxygen-17 isotope to oxygen-16, which suggests that they formed further away from the Sun than ordinary chondrites. They are named for the site in Kenya where they were originally found. Carbonaceous chondrites have a high abundance of organic compounds, which indicate that they formed at great distance from the Sun. Chondrules are tiny mineral beads that are generally smaller than a grain of rice and comprise about 80% of the weight of chondritic meteorites. Chondrules are spherical and contain a variety of small mineral crystals. It is thought that chondrules acquired their spherical shape when clumps of stellar dust were heated and partially melted. Some chondrules have a layered structure, indicating that the accretion and flash melting process was repeated multiple times. The time of formation of chondrules ranges from 4,567.32 to 4,564.71 million years ago, which is the very beginning of our solar system. Chondrules have been made experimentally in the laboratory by aiming high-energy lasers at various minerals to melt them. Chondrules of different types are created depending on the temperature, cooling rate, and chemical composition. Rapid crystallization from a supercooled melt produces spherules with rimmed, radial, barred, and glassy textures similar to those of many meteoritic chondrules. Some of the mechanisms that produce chondrules in the solar system are nebula lightning from static electricity in turbulent dust clouds. Astronauts have found that in a zero-gravity environment, small particles that are charged with static electricity start to clump together. Impacts into meteorite regolith. Meteorites covered in regolith absorb most of the energy of an impact. Local heating can cause melting, and a long flight time of the molten ejecta can allow the interior of the spherules to develop crystals. Products of hot inner nebula. A protoplanetary dust cloud with a hot center would provide the conditions for accretion and heating of particles. The repeated circulation of particles through hot and cold regions would lead to multi-layered structures similar to those of hailstones. Flash heating event. Solar flares could provide flash heating of nebular dust for the formation of chondrules. The study of chondrites gives scientists a glimpse of the conditions that existed during the formation of the solar system. Keep your eyes on the sky and watch out for falling rocks. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.